So when you were looking at these homework assignments last night, I'm assuming several of you found some that were relatively easy, some that were not so easy, right? So let's make sure that we're taking good notes today, please and thank you. What's number 4 say? Okay. So if you notice, right, do I have one fraction or multiple fractions? Multiple, and they're separated by a plus or minus sign. So in order to actually combine these, what do I have to do? In order to subtract fractions, what must I have? The same denominator, right? So if you take a look, now the issue that y'all run into is some of you know some of the fraction rules, but you don't know all of them. Okay, so the important thing is, are those two fractions on the same side of the equal sign or on different sides of the equal sign? Same side. So in order to combine fractions that are on the same side, you just have to have the common denominator. All right? So do we have a common denominator there? Yeah. So do the bottoms already match? Yeah. So all I do is I just do the math on top. So I get x minus 4 over 16x squared. Now, is there anything that I can do to factor? So now does everybody recognize that I have just a single fraction? So now this is just like what we did in the last section, okay? Is there anything that I can do to make x minus 4 smaller? No. Is there anything that I can factor out on 16x squared? Okay, how do I know that? Because if this cannot be factored, then it's got parentheses on it, so it's locked. So the only way that I could make things smaller is if I had x minus 4 exactly looking like that on the bottom as well. Do I have an x minus 4 down here? No. Can I make this so that it has an x minus 4? No. So this is it. Everybody okay? So one of the issues that you run into here is that when you run into a problem that is not as involved as some of the others, you think you're making a mistake. Okay? So your process is combine fractions to get a single fraction, reduce the fractions, cancel top to bottom, you're done. Everybody all right with that kind of a process, yes or no? Okay, so those are the primary steps. Each problem is going to look a little bit different, but that's what we're going to be focusing on. All right, so number 21. Can somebody read number 21 for me, please? X plus what? 1? And is there an equals or anything? All right, directions just say simplify. Okay. So, again, do I have one fraction or two? 2. So in order to add or subtract two fractions, what must I have? Common denominator. So what we want to ask ourselves is, are the current denominators factored? So x minus 3, is that factored? Can that get any smaller? No, so this is factored, right? X plus 1, can that get any smaller? So this is factored as well. Why does that matter? Well, when you find a common denominator, all you do is you take the factors of the first denominator, the factors of the second denominator, and you multiply it all together to get the new denominator. All right, so are there any factors that are repeated in both? No. So what is my new denominator? What's my common denominator going to be here between x minus 3 and x plus 1? X minus 3 times x plus 1. That's a minus, I think. Okay? So that's all we're doing is we're multiplying the denominators together just like normal. Okay? Any questions on that? Yes or no? All right, so now that we have the denominator set, we can deal with the numerators, okay? So what is not in the original denominator here, but is in our common denominator here? X plus 1. So if I have to take the old denominator of x minus 3 and multiply it with an x plus 1 to get my common denominator, what do I have to do to its numerator? Multiply by the same factor. Everybody okay with that? So on top, I'm going to get 9 times the x plus 1 to maintain the equality of the first fraction. So we take the old denominators and we multiply them together to get the new denominator. And then for the numerators, we take whatever is in the common denominator that is not in our original denominator and multiply the numerator by that. Which part? Okay, so if I'm multiplying the denominator by x plus 1 to maintain equality, what do I have to multiply the numerator by? X plus 1. So whatever you multiply the bottom with, you have to multiply the top with. Yeah, but sometimes it gets a little weird when you have multiple factors. That's why I want you to get into the habit of asking yourself, what's in the common denominator that is not in the original denominator? Anything that's in the common denominator that is not in the original, you have to multiply with the numerator. Okay, so if I had 3 pieces down here, the 2 that are not in the original fraction have to get multiplied with the numerator to maintain equality. Everybody okay with that connection? All right. So now let's take a look at the second fraction. So what value is in the common denominator that is not in its original denominator? The x minus 3. So if I have to multiply x plus 1 with x minus 3 to get the common denominator, what do I have to multiply its numerator with? So I'm going to take the 2x, which is the original numerator, and then multiply it with the x minus 3, because that's the piece that's in the common denominator that is not in the original denominator. Is that starting to make some sense? Yes, no, maybe? Let me do this again a different way, and you guys will see the connection. Okay, if I had to guess, it's just the notation up here is giving you a hard time, so give me one sec. So if I gave you this and I said, what's the common denominator up here? If you don't recognize the common denominator right away, what do I always tell you to do with the denominators? Just what? Multiply them together. So I'm going to take the first denominator times the second denominator, first, second. Everybody okay with that, yeah? All right. So what do I have to multiply with x minus 3 to get this denominator here? So if I take this and I have to multiply by an x plus 1, I have to multiply the top by x plus 1 because what's the only number I'm allowed to multiply by that doesn't change anything? 1, which means that it's anything divided by itself. So if x plus 1 times x minus 3 gets me the common denominator, that means that I'm multiplying the x minus 3 with an x plus 1. So to maintain equality, if I multiply the denominator by x plus 1, I also have to multiply its numerator by the exact same piece. So that's how I get 9x plus 1. Does that make more sense? Okay, so now we move on to the second fraction. Okay, what do I multiply with x plus 1 to get this denominator here? So if I multiply the bottom by x minus 3, what do I have to multiply the top by to maintain equality? X minus 3. So x minus 3 times x plus 1 gets me the denominator, which I already have written. And then on top, I'm going to have 2x times x minus 3. Everybody okay with that? Okay, so now you get 9 times x plus 1 plus 2x times x minus 3 all over the common denominator of x minus 3 times x plus 1. We're almost there. So is everybody okay with step 1 and 2? Back to where I started. I cut out the middleman and just jumped to step 2. Again, you can do this either way. So the issue isn't the math, it's just the way it looks. Okay, if you want to multiply by the fractions, go ahead. But I'm going to warn you, some of these are going to have 2 or 3 terms, and it's going to get a little bit messy, so just be careful. Okay? So I tend to write things out this way because it's a lot cleaner. But if you notice, my step 1 is the exact same answer that we had for step 2. So instead of writing it all out, I'm tracking it in my head. Okay, so it's the exact same math, it's just a different way of analyzing it. No, because there's no equal signs. You can only cross multiply if it's a fraction equal to a fraction. Okay, so now, back to answer Cardell's question. We can't start canceling from top to bottom yet. Why not? What's creating the problem? What's in the way? The plus sign. So what I have to do is I have to multiply everything out, get rid of all of my parentheses, combine my like terms, factor, and then I can cancel. Okay? So I'm going to just distribute here. I get 9x plus 9 plus 2x squared minus 6x all over x minus 3 times x plus 1. So any questions on the multiplication step? Okay, so now combine your like terms. So I'm going to get 2x squared plus 3x plus 9 all over x minus 3 times x plus 1. All right, so can I factor anything out of the numerator? No, I have a 2, a 3, and a 9, right? So what am I going to have to use to factor this? The root. Now, you are welcome to use sidebars. Does anybody here know what a sidebar is? Okay, like in court, right? A sidebar is where you stop the trial, so that way you can have a private conversation, okay? Instead of trying to factor this down with the LaRue method while it's still a numerator, you can do the work on a separate sheet of paper and then just bring it back in as the numerator. So what I mean by that is I'm just going to, over here on the side, 2x squared plus 3x plus 9. And now I'm going to just do the LaRue method over here on the side, and then I'll just drop the answer back into the top so I don't have to worry about writing those fractions all the time. Everybody okay with that? So you're welcome to use separate paper or use a part of a paper where you do some work, right, without writing the entire fraction, because I know it can get confusing. So who remembers the LaRue method? What do we do? By the 9, right. So I get x squared plus 3x plus 18. All right, and then we factor like normal. So can you think of two numbers that multiply together to get 18, but when you add them, you get 3? 6 and 3, if you add them, are you going to get 3 from that, though? Are there two numbers that multiply together to get 18 that when you add them, you get 3? No. So this cannot be factored, so you're done. Is there anything that can cancel from top to bottom? No. The only thing that could happen is if you get the exact same thing on top and bottom, right? But if I foiled this together, x minus 3 times x plus 1, is that going to turn into 2x squared plus 3x plus 9? No, that's mathematically impossible, right? So there's nothing I can cancel from top to bottom. Any major questions on that? I know that one's kind of weird, but it's the process that matters. I know that's going to sound weird. It's not the end result. I want you to focus on the process. So everybody okay with the multiplying to get a single fraction as far as common denominators go, and then multiplying out, grouping like terms, and getting to this point right here? Are there any questions on those 3 steps? So you could solve it, right? Julian, you could use the quadratic formula to solve, but that's not what they're asking you to do yet. Okay? So if it can't be factored, and it cannot cross-cancel, we're done. But the whole point here is take multiple fractions, write it as one fraction, knock it down to factors, cancel from top to bottom if possible. That's all we're doing. All right, it's actually 3 steps. Everybody good? All right, let's 28 say. So, first things first, right? Do I have 1 or 2 fractions up here? 2. So in order to combine them, I must have a common denominator. So in order to find the common denominators, I need to know what are the factors of my denominators. So x minus 3, can that get any smaller? Okay, so that's just staying. X squared minus 2x minus 8, can that be factored? Yeah. Okay, so what two numbers multiply together to get 8, but when you subtract them, you get 2? 4 and 2, right? Okay, are the signs going to be the same or different? Different, and the bigger one is negative, so it'll be negative 4 plus 2. Everybody all right with that, yes or no? Okay, x minus 5, can that get factored? Nope, so it stays as x minus 5, and then on the bottom, all right, x squared is x squared. Two numbers that multiply together to get 32, but when you add them, you get 12. 8 and 4, the signs are going to match, and they're both negatives. Negative 8, negative 4. Any questions on this point, yes or no? All right, so this is where we have to do work before we can do work. So this is the problem that I'm caring about now. I don't really care about the original anymore. This is what I want to look at, okay? So can anybody tell me what's the common denominator between x minus 4, x plus 2, x minus 8, and x minus 4? Okay, so x minus 4 is in both, right? So if it's shared, I only need it one time. So I'm going to have an x minus 4 in the bottom of my common denominator because both of my original denominators have an x minus 4. All right, so x minus 4 is in both. Now, is x minus 2 in both? No, so this is a singleton or a distinct factor. So I need that. Yeah, did I say? Oh, I'm sorry, x plus 2. So because x plus 2 is one of my factors, I need it, right? And what's the only factor that's left? X minus 8. So is everybody okay with how I set up my common denominator? Okay, it's basically you factor the bottoms, and any factor that shows up, we have to keep. All right, but that's what they mean by common denominator. It's all of the stuff combined, right? Okay, so now I have to set up the tops, right? So what's my numerator for the first function? X plus 3. So that's going to stay. Now, I'm going to have to multiply it by something because I changed the denominator from this to this, right? So x plus 8 is the new x minus 8 is the new term in the common denominator. So if it's new to the bottom, I have to make it new to the top. So I'm going to have an x minus 8 up here. Is everybody okay with that? Okay, so look at the second fraction. What's new to the bottom from the old denominator to the new denominator? The x plus 2. So if that's new to the bottom, it has to be new to the top. So I'm going to get x minus 5 times x plus 2. So we're going to have to FOIL both sets, distribute the -1, and then group our like terms. FOIL out the top. Now, the nice thing is that the bottom's already factored, right? I'm not going to touch it again. Now that I've got the bottom factored, I'm just working on the top, and that's it. Okay? So distribute on top. We're going to get x squared minus 5x minus 24. Everybody okay with that, right? And then minus parentheses, x squared minus 3x minus 10, like that. And then I just have my bottom here. X minus 4, x plus 2, x minus 8. All right, so any questions on that bit? Yes or no? Okay, so let me scroll up. So now I have that negative sign, right? So you guys remember from last year how to distribute a negative. So I'm going to get x squared minus 5x minus 24 minus an x squared plus 3x plus 10 all over what? X minus 4 times x plus 2 times x minus 8. So all I did is I took the -1, distributed it into every piece in the second numerator. Yeah, so all it does is flip the signs, right? Positives become negatives, negatives become positives. So now combine your like terms, right?
Yeah.
So is there anything that can combine with x squared? No. Negative x squared. So what's x squared minus an x squared? All right, what's negative 5x plus 3x? What's negative 24 plus 10? Negative 14. Okay, is there anything that I can factor out of the top now? Not just 2, but negative 2. So I'm going to pull out a negative 2. That's going to leave me with x plus 7, right? Okay. So now I have nothing but multiplication on top, nothing but multiplication on bottom. Can anything cancel from top to bottom? No. So you're done. Yeah. The stuff last year, was preparation for this year. Okay? All of those skills that we used last year, chapters 5, 6, 7, this is where we put them all together. It's why chapter 8 is so difficult, is because you are actually combining different processes from 4th grade all the way through to last year. So it just seems really huge. If you focus on just the individual steps and use baby steps, it makes it feel less like a mountain and more like a series of hills. So the trick there is if you recognize that everything for x in the denominator is positive, you want to try to make your x's positive to see if anything can cancel. Okay? So that's why I knew to pull out a negative 2 instead of just 2. Now, if I would have had a negative down here, I would have left it to check and see if something happens. Okay? Woo! All right. 32. This actually is not, this is going to be a heck of a lot shorter than that last one. So, again, the important thing here is that we're trying to knock things down into single fractions. If I have a single fraction over a single fraction, then this is exactly what we did in the last section when we were dividing. But you all said was super easy. Okay? Yes, sir. It doesn't matter with this one because I have 2 fractions on top and 2 on bottom. I'm going to work on top because I was always taught to go top to bottom, but it actually doesn't matter. It'll be the exact same work, okay? So if I'm working on top, I have to get a common denominator, right? So what's the common denominator on top between 1 and x? 1x. So we're going to use the crisscross across, right? So what's 15 times x? Minus what's 2 times 1? 2 times 1, bro. 2. And then on bottom, what's 1 times x? Everybody okay with how I'm recombining that subtraction problem into that singular fraction? Yay. Any questions on that part? Okay, so now, how do I divide fractions? By the denominator. So, I take the top fraction as it sits. I multiply by the reciprocal of the denominator, which is the second fraction from the bottom here. And I get 5 over x plus 20. Now I want to try to factor. 15x minus 2, can that get any smaller? 5, can that get any smaller? X, can that get any smaller? X plus 20, can that get any smaller? So your answer is 5 times 15x minus 2 all over x times x plus 20. I'm not going to make you recombine all of this stuff. Boom. And that's 32. So 32 is actually the easier one compared to 28, which was a monster. I'm waiting for like Bear Grylls to go fight it in the woods. All right, number 33, I think I have time for. Yeah, I got time. Look at you guys. I got 10 whole minutes. So on top, 1 fraction or 2. So there's nothing for me to do right now. Okay, the only thing that you might want to do is factor. So can 16 be factored? Yeah, but it doesn't help, right? What about x minus 2? No, so it's just going to stay and hang out. Just going to be chilling like a villain up here. All right, so now on bottom, do I have the same denominators? No, but again, I want to know, are the bottoms factored? So is x plus 1 factored? Is x factored? Okay, so to get the common denominator, I'm going to again use cross across. Okay? So what you do is you take numerator times denominator. What's 4 times x? Okay, so I get a 4x. The sign between the two fractions, okay, this time it's a plus, so I put a plus. The cross, numerator to denominator, what's 6 times x plus 1? 6x plus 6. Everybody okay with that, yes or no? Yeah, if you can combine those steps, feel free to, because we're going to have to anyway, because we have a plus sign, right? Everybody okay with that? So you can write it as 6 parentheses x plus 1 and then distribute later, or you can distribute as you're moving. I'm going to have just the across the denominators. So I'm going to have x plus 1 times x. Because it's a denominator and I want things factored if possible. So you can do that, but you're going to wind up factoring it back to where it was in the next step. So I don't like doing the same work twice. All right, so combine what you can on top. What can you combine? So you get 10x plus 6 all over x plus 1 times x. So now, how do I divide fractions? Multiply by the reciprocal of the denominator. So I get 16 all over x minus 2 times x plus 1 times x all over 10x plus 6. 16, can I factor anything out of 16? No. What about x plus 1? Can x plus 1 be factored? No. Can x be factored? No. Can x minus 2 be factored? Can 10x plus 6 be factored? Yeah. What's in common to 10x and 6? 2. So that leaves me with 5x plus 3. So now can anything cancel or reduce from top to bottom? One thing. What's 16 divided by 2? So this becomes an 8, and that's gone, so I get 8. You can write it a lot of different ways. It's 8x times x plus 1 all over x minus 2 times 5x plus 3. And that is your final answer.